Welcome to Object-Oriented Programming course. In today's lecture, we will learn the last two UML diagrams remaining in the first module. That is, we will learn activity diagram and state chart diagram. Activity diagram. It's a behavior diagram. This is another important behavior diagram in UML to describe the flow of control in the system. An activity diagram visually represents series of actions or flow of control in a system. It is similar to a flow chart or a data flow diagram. It is also called object-oriented flow chart. It represents workflows of stepwise activities and actions with support for choice, iteration, and concurrency. Here you can see a normal flow chart, and here you can see an activity diagram which is also representing similar control flow. So in representation you can see some differences. Apart from that, compared to a normal flow chart, in activity diagram there are provisions to represent concurrency, and it is specifically for the representation of object-oriented system. Activity diagram demonstrates the logic of an algorithm. It describes the steps performed in a UML use case. Usually a business process or workflow between users and the system. Simplify and improve the process by clarifying complicated use cases. So it will give you more clarity on the steps involved in that particular operation. So there is a chance of improving the operation by analyzing it deeply. Activity diagram models software architecture elements such as method, function, and operation. Here you can see an example for an activity diagram. This is start of the activity. This is an open article published. So author is publishing an article. Now it is now the next activity is with the moderator. Moderator is checking that. He is checking after he is deciding whether to approve or not. Once it is approved, status is changing to published and it reaches final stage. If it is rejected, then it is getting notified and process terminates. So it is conveying the flow of control, and it is very much similar to the flow chart, but there are different notations, and it is capable of representing the object-oriented system. Let us see the details. Let us learn the basic components of an activity diagram. We said an activity diagram is similar to a flow chart. So in a flow chart, we have nodes, connectors, like that. So here also the major components are like nodes, then the connectors, that is nothing but the control flows. Then there is an additional concept, that is partition, that is to group the nodes. In nodes there are different types of nodes. Action node that represents a single step in the activity wherein the user or the software perform a given task. Next type is start node, symbolizes the beginning of the activity represented by a black circle. Then the end node that represents the completion of the activity. It is represented by an outlined black circle. Then control flow, that is nothing but the connectors between the nodes. It shows the control flow between the steps in the diagram. And the last item was the partition, that is to organize the nodes in the activity diagram. Let us see the details of each of them. Okay, in nodes we already mentioned what is a start symbol. It is represented as a black circle, portrays the beginning of a set of actions or activities. Then action symbol, a task to be performed. It is a single task, so it is represented with an oval. An activity symbol, indicates a set of actions. See, it is singular and it is plural. That make an activity symbol indicates set of actions that make up a modeled process. Includes short description within the shape. In both cases, actually you can give the short description within this box. Then the object name, it is represented with a rectangle, a node that is used to define the object flow in an activity. Then flow final symbol represents end of a specific process flow. It does not represent the end of all the flows in an activity. So it is with a circle with an X mark within that. That indicates flow final. It represents only the completion of a particular flow. It does not indicating the completion of the entire activity. Only a particular control flow is getting completed. That is the meaning of this. And in the object, see, I said a rectangle can represent the object. Within that, you can give the name. That naming convention, that is, we have already seen. See, in UML diagrams, whenever you give the name of an object, that syntax is something like object name colon class name. So object name colon type is nothing but the class name. Okay. Now we learn what is flow final symbol. Next thing is end symbol. That indicates stop all control flows and object flow in an activity diagram. It is represented by an outlined black circle. And in the case of flow final symbol, it is telling that one particular control flow is getting completed. There is no effect on the parallel flows. They will be continuing. But end of flow is telling that all control paths are getting completed. That is indicating the end of your activity diagram. Okay, notations for control flow. Action flow or control flow referred to as path and edges. They are used to show the transition from one activity state to another. Join symbol or synchronization bar. See, this action flow is represented by this line with an arrow. Okay, join symbol or synchronization bar combines two concurrent activities and reintroduce them to a flow where only one activity occurs at a time. Represented with a vertical horizontal line. See, this is nothing but the synchronization bar. So at here you have two threads. You are reaching the synchronization bar. Now from synchronization bar only one control path will go out. So this is join symbol. Fork symbol, it is actually reverse logic. It is splitting a single activity flow into two or more concurrent activities, symbolized with multiple arrowed lines from a join. So here control is reaching here from synchronization bar, two control paths are going out. That means two threads are getting spawned from that point. Next thing is loop node, a structured activity node that represents a loop with test, setup, test and body. So like this dashed rectangle, rounded rectangle, you can represent a loop. Within that there will be different partitions to represent the setup, test and the loop body. We will see an example. The decision node. See, in flowchart we have used conditions, diamond symbol. Here also in the same line, decision box represents a conditional branch point or decision node. A decision node has one input and two or more outputs. Based on the condition, output will go in different directions. Guards are statements written next to the decision diamond in square bracket. Based on this condition only, whether that control path is true or not, that is decided. So this condition is written in guards. Accepting an event or action. This action, this is indicating accepting an event. Okay, this action waits for an event to occur. After the event is accepted, the flow that comes from the action is executed. So by default it will be waiting for a particular event. Once the event reaches, then only the control flow proceeds. Sending signal, that is also another kind of action. Sending a signal means that the signal is being sent to another accepting activity. That is sending activity is represented like this. This is signal accepting activity. Next thing is notation for grouping, that is known as swim lane. A swim lane and partitions. A way to group activities performed by same actor on an activity diagram, or to group the activities in a single thread. So you can group it based on different conditions. One way is to group the activities performed by the same actor, or group the activities happening in a same thread. That is up to the designer to group. So swim lanes are used for grouping related activities in one column or row. Swim lane can be vertical or horizontal. It adds modularity to the diagram. So here you can see vertical swim lanes. Here you can see horizontal swim lanes. There is no difference in the meaning. In both cases, we are actually grouping related activities. So here, first partition represents the customer, second partition represents seller. You see that partition name is telling, see, the partition name is mentioned here. In this diagram, this partition is actually accounting department, second partition is customer. Let us learn the activity diagram syntax in detail. So start node, each step in the system, then the decision, steps are proceeding. See, this is join symbol. This is fork. Till this point you have only one thread. From here you have two threads executing these two things concurrently, parallel activities. Now you are actually joining those two threads, and again it is proceeding getting completed as a single thread. See, here you can see a loop. This is the start of your activity diagram. Then this dashed rectangle is curved rectangle is representing the loop. First part is the setup, loop setup, that is the loop initialization. In a for loop you have initialization, condition, then another part you will be having the loop body. In the same way, this is the loop setup, initialization. Now this is the test. Okay, see here you can see that if condition is true, then it is proceeding to the loop body. It will be keep on repeating, and the else case is not mentioned, that is implicit. If the condition fails, you will come out of the loop. So no need to mention the here true case is mentioned, false case there is no need to mention the false case. If it is false, you will come out of the loop. Okay, another notation which I wanted to explain is the flow final symbol. Here you can see start of the activity, action A. Now you have one branch which is going the exception case. This is indicating that this particular control flow is terminated, and this path will continue without any implication. Let us see an example for a student enrollment. See that logic is something like an applicant wants to enroll in the university. The applicant hands a filled out copy of the enrollment form. The registrar inspects the form. The registrar determines that the form has been filled out properly. The registrar informs the student to attend the university or overview presentation. The registrar helps the student to enroll the seminar. The registrar asks the student to pay the initial tuition. So this particular system is represented like this. This is the beginning. Then fill out the this is the first thing. Candidate fill out enrollment form. Then then it is getting verified. If it is incorrect, then he may avail some help. If it is fine, then enroll university. Now once the enrollment starts, then two things are happening parallelly. Attend the university overview presentation. Another parallel flow is enroll seminars, make initial tuition payment. Now that process is control paths are actually synchronized. Now the process is completed. Another example is staff expense submission. In this case, you can see the concept of swim lane. There are three partitions: consultant, accountant, payroll service. So consultant is actually filling out the form. These two objects are actually getting transferred. Now in the accountant is validating the expense. If it is valid, enter the expense in the payroll system. Now it is getting updated in the payroll file. This is object. is not an activity. It is getting updated in the payroll file. Now in the as the next activity, pay employee, then the activity completes. So that is all about activity diagram. Next diagram is state chart diagram. You can see state chart diagram or state machine diagram. It is also a behavior diagram. It is used to capture the dynamic aspects of a system. It is also called state machine or state transition diagram. A state is a condition or circumstances of an object. Usually, the state will be active. That means it is performing some activity. Inactive means waits for some event. So, normal states will be active or inactive. It defines different states of an object during its lifetime, and these states are getting changed by the events. A state chart diagram describes the transition from one state to another in response to some event. Shows discrete behavior of a part of the design system through finite state transitions. So here focus is on the uh, different states and events which are causing state transitions. Need for a state chart diagram or state machine diagram. The primary purpose of a state chart diagram is to model the interactive system and define each and every state of an object to represent the events responsible for change in the state. We do not show what process causes these events. That is not the concern in this state chart diagram. Here we are representing states and the events which are causing transition, means state change. See here, to understand the reaction of objects or classes to external stimuli. So that is the purpose of this state chart diagram or state machine diagram. You can see this example. This indicates the start and this indicates the completion. And the states are power on, operating, idle, power off. 4 states are mentioned. This is not activity or any operation. These are states. Okay, this is actually the case of a toaster. So bread toaster. So the entry is okay. You turned on. Now it is in the powered on state. Now it is moving to the operating state. Up temperature, lower temperature. Okay, it is moving to the operating. That means heating. Heater on. Exit means pull out bread. Once you remove the bread from the toaster, it can either go to idle state, or once you turn off, it will go to the power off state. Notations for state machine. Initial state. In the case of activity diagram, we saw initial activity. Here it is initial state. Representation is same, means symbol is same. The initial state symbol is used to indicate the beginning of a state machine. Final state, the symbol is used to indicate the end of a state machine. A state machine diagram. A state is represented with a rounded rectangle. A state represents the condition or circumstances of an object, of a class, at an instant of a time. At a particular instant, what is the state of that object? It can be active or inactive. Simple state implies no nested substates. Okay, that means there will be nesting of the states will not be there. Transition is like changing from one state to another. It is a solid arrow which represents the path between different state of an object. So this is transition. This arrow, this indicates that it moves from this state to a new state. The arrow is labeled with the event which is causing the transition. So here you will give which event is causing the transition, which event is the reason for that state change. Okay, whatever I said, that is simple state. At that time I said there is no nesting, means there won't be any state within the state. And now we will come to the composite state. A composite state is a state that has substate or nested state. UML 2.4 defines composite state as the state which contains one or more regions for substate. Region is something like these dashed lines, so it will separate the composite state into different regions. Orthogonal state. A composite state with two or more regions is called orthogonal state. If there are two or more dashed lines within your separating the states in a composite substates in a composite state, that is orthogonal state. History state. Okay, see here this particular thing is a composite state. This also a composite state only. Here you can see the region, and the first region, see, this is actually apply brake. See, this is the braking state machine, a braking system state machine for a car or vehicle. So first region is for the front, second region is for the rear braking. So that means your apply brake is having two regions within it. It's a composite state. And a composite state with two or more regions is known as orthogonal state. Next thing is history state, which is used to remember the previous state of a state machine when it was interrupted. See here, you can see the state machine for a washing machine. In a washing machine, during the time of execution, power failure can happen. If a power failure happens and when the power comes back, the washing machine can actually start the previously interrupted activity. That means your washing completed, rinsing completed, spinning was going on at that time, power interruption happened. When the power comes back, if it is a history state implementation, then it won't start from the beginning. It will directly start from the previously interrupted state. So such history states are mentioned with this circle and an H symbol. So this is history state, which is used to remember the previous state of a state machine when it was interrupted. So it can remember, that is history state. Another notation is choice. Pseudo state contains condition depending upon the result of an evaluating guard condition. Guard condition is nothing but the text given in the square bracket. Depending upon the result of the guard condition, a new path is taken for program execution. Fork. Pseudo state vertices to serve to split an incoming transition into two or more transitions terminating on orthogonal target vertices. So it is actually, see here you can see the case of a fork. So it is branching into two sets and which are separated by a region. This S and Q belongs to different regions. So that is fork. Join is reverse. From two regions, join pseudostate merges several transitions originating from source vertices in different orthogonal region. Means from different regions, the source vertices are from different regions and it is actually getting merged. That is the concept of join. Here you can see a state chart diagram example for ATM. First start card swipe, then it will wait for the pin. Once you enter the pin, it will move to pin verification. Then it will be authenticated. Or if pin is rejected, it will again go back for the pin waiting. Okay, another example. Okay, this is university state diagram. Okay, the composite state enrollment is made up of, here you can see a composite state which is having other substates is made up. The composite state enrollment is made up of various substates that will lead students enrollment process. Once the student has enrolled, they will proceed to being taught and finally final exam. So this composite state indicates the registration process. Means initial state will be proposed, scheduled, open for enrollment. All the seats are full. Once enrollment date is close to enrollment, So here this entire thing is representing the enrollment process. Once the enrollment is completed, it will be moved to being taught. Then another state is final exam. Here also you have exit final state options. From the being taught state, student can drop out. From the final exams, then it is closed. Means after the exam also it can come to the final state. From the registration time also it can actually getting cancelled. So all these indicates the final stage. So that's all about the state machine diagram. So we have completed all the targeted or the required UML diagrams for our first module. So we learned class diagram. From the structure diagram we learned class diagram, component diagram, deployment diagram, package diagram. These three were not mentioned in the syllabus. And from the behavior diagram, we learned use case diagram, sequence diagram, collaboration diagram, state chart diagram, and activity diagram. Okay, details means highlighted features are mentioned here. You can have a look at that. Here, one case study is given. This is for a library management system. Use case. This is the use case diagram. You can pause here and see the details of each use cases and the other include or extend use cases. So for the library, uh, there are two types of members: student members and staff members. Each member interacts with the library system for authentication and login. A member can request a book, member can reserve a book, member can renew a book, member can return a book. The other type of actor is librarian. Librarian can actually add record, add user, print fine receipt, delete book, update book. These are the means use cases directly operated by the system. In between you can see several use cases which are enhancing the or extending the functionality of other use cases. Then that system can be represented using a sequence diagram. So the lifelines are member, librarian, book, transition. You can see the here request book thing is represented. Member is requesting for the book to the librarian. Librarian checks the availability of the book. Then book is available. Okay, based on that he can create the transaction. Okay, all these things are. This is a sequence diagram for the library management system. Another thing is the communication or collaboration diagram. So here also different objects are mentioned and the message flow and the links are also mentioned. You can check the numbered messages and understand the messages exchanged between the objects. Another thing is the activity diagram for the library management system. Inquiry about book, check the availability. If it is available, not available, book not available. If it is available, then proceed. That control flow is mentioned in the activity diagram. Here, this is the state machine or state chart diagram for the library management system. Different states are represented. Validate member, idle, check availability of book, returning book, calculate fine, issuing. So and there are state transitions. These are the different different messages, events, or the stimuli causing the state transition in the library management system. So understand these kind of representation. So in the examination you may be getting a problem like this. In that case, for such a problem you should be able to prepare use either use case diagram, sequence diagram, class diagram, whatever. So as per the question you should be able to create the corresponding UML diagram for that problem. We have completed the UML diagrams part in the first module. Now we need 2 more lectures to complete the introduction to Java part. With that, we can complete the first module. Thank you for watching.